In addition to the use of sed for selecting lines, we also saw briefly how we can do similar tasks with the awk command. Awk embodies a small specialized pattern scanning and processing language. Through its influence on the Perl scripting language, awk is considered an important predecessor of modern scripting languages such as Python and Ruby. Covering all awk's capabilities would take an entire course. Still, in this unit, we'll see some motivating examples of practical applications, demonstrating its power and applicability. We often use SOAK for aggregating data.
As a first example, consider the task of obtaining simple descriptive statistics from some data. In our case, I fetch a large archive file with the source code of the Linux kernel. I decompress it and pipe it through tar in order to obtain a listing of its contents. I save these in a file named contents.txt. Looking at these contents, we observe that they contain the permissions of each file, its owner, its size, the date and time, and the file name. To get some summary statistics of these contents, I can use an inline awk script. For each line, I specify as an action that the variable named size is incremented by the third field. See the $3. This contains the size of the file. In this way, I calculate the total size of all files. I also use another variable called n, which is incremented by 1 in order to count the number of files. This is also called a counter. A pseudo-predicate named end allows the subsequent action to run at the end of the script after all lines have been processed. This prints the total size, which is stored in the size variable, the number of files included in the counter, and the average file size calculated through the division of the two. Running this awk script on contents.txt, we get the total size of the archive, the number of files it contains, which is about 55,000, and the average file size, about 10 kilobytes. As a second example, let's obtain from contents.txt the file extensions associated with the largest amount of code. Again, I use an inline awk script. First, I run a substitution command to substitute anything followed by a slash with nothing. I do that to remove the path from the sixth field, which contains the file's complete path, and only keep the file name. Then, I remove any dot followed by a star, followed by an actual dot, so anything to an actual dot. If this substitution command doesn't succeed, it means that the file has no extension, so I skip it with the next command. For files that do have an extension, I store the extension, the sixth field, in an index in an associative array, dictionary in Python or map in other languages, named size. As a value for this index, I keep the total size of the files with a particular extension. To do that, I increment the existing value by the third field, which, as we saw above, contains the file size. In the end, I iterate through the associative array size with an index I. For each array element, I print the extension, the index, and the total file size corresponding to this extension. Finally, I sort the result in reverse numerical order by the second field and select the first few records with head. Thus, we get the file extensions associated with the largest amount of source code. We see that first come some C files, then the header files, the text files, the assembly files, and so on.
As a broader example, let's see how we can use an awk script to automate the extraction of email attachments.
Consider the following first few lines of an email message. Email messages containing attachments use a separator named boundary to separate one attachment from the other. Let's write a small awk script in a here document to save those attachments into distinct files. Similar to Unix shell and sed scripts, we specify hashbang bin awk in the first line to denote that the script will be executed through the awk program. With the -f option, we specify that the associated file is a script. I use a variable named SEP to pass to awk the attachment separator. So, if $0, which means the whole line, matches, that's what the tilde symbol stands for, the beginning of a line, followed by the specified separator, followed by the end of the line, I increase a counter named out. Keep in mind that in awk an expression followed by another denotes the concatenation of the two. When the counter is increased, I print the line to a file whose name starts with file dash, continues with the value of the out counter, and ends with the suffix .att for attachment. Now, let's run the awk script on the above email message, specifying as a separator the boundary included in it. Listing the contents of the current directory, we verify that all 37 attachments contained in the message were separated and saved into distinct files.
This concludes our unit on processing data with awk. As always, stay with us.